Hello, I am Professor Gurpreet Dhillon. Let me begin by asking, have you ever heard someone say, science is completely objective? It has nothing to do with opinions or values? At first glance, that sounds exactly right. After all, science is supposed to be about facts, evidence, and experiments, not politics, ethics, or personal beliefs. But here's the interesting question. If science is truly objective, why do scientists sometimes disagree, even when they're looking at the same evidence? Why do governments fund some research but not others? Why do ethical debates influence fields like genetics, artificial intelligence, or climate science? The answer is that science has always been influenced by values. The real philosophical question isn't whether values exist in science. They clearly do. The question is whether those values undermine objectivity or whether they actually help make science more objective. Today, we're exploring one of the most fascinating debates in the philosophy of science, the relationship between objectivity and values. For centuries, science has represented humanity's best attempt to understand reality as it actually is, not as we wish it to be. Objectivity means that scientific conclusions should not depend on who performs the experiment. Whether you're in Tokyo, London, Nairobi, or New York, gravity behaves the same way. Water still boils at roughly 100 degrees Celsius at sea level. DNA has the same molecular structure. Scientific knowledge is supposed to transcend individual opinions, political ideologies, and cultural beliefs. This ideal became especially influential during the early 20th century through a philosophical movement known as logical positivism. Logical positivists believed that science should concern itself only with statements that could be verified through observation and experiment. They also drew a sharp distinction between facts and values. Facts describe what is. Values describe what ought to be. Science, they argued, should deal exclusively with facts. Questions about morality, politics, or religion belonged somewhere else. The philosopher Rudolf Carnap believed that scientific reasoning should be as objective and value-free as possible. Values might influence where scientists get their ideas, but once research begins, evidence alone should determine whether a theory is accepted or rejected. This became known as the value-free ideal of science. A similar vision appeared in the work of Karl Popper. Popper argued that science progresses not by proving theories correct, but by trying to prove them wrong. A scientific theory must always be open to falsification. If repeated experiments contradict a theory, scientists should abandon it. For Popper, objectivity wasn't about scientists being personally unbiased. Instead, objectivity came from following rigorous methods that constantly exposed ideas to criticism. Individual scientists might have preferences or prejudices. But if every theory must survive severe testing, those personal biases become less important. Objectivity, in this view, is procedural. It comes from following the rules of scientific inquiry. But can science ever be completely value-free? During the second half of the 20th century, philosophers began questioning whether this ideal was actually achievable. One of the first challenges came from Norwood Russell Hanson. Hanson argued that observation is theory-laden. In other words, scientists don't simply look at the world like neutral cameras. What they notice depends on what they already know. Imagine showing an X-ray to a radiologist and to someone who's never studied medicine. They're looking at exactly the same image, but they don't see the same thing. The expert immediately recognizes fractures, tumors, or infections. The novice sees shades of gray. Observation is always filtered through concepts, expectations, and prior knowledge. This means that data never completely speak for themselves. They always require interpretation. Another important challenge came from Pierre Duhem and later Quine. They argued that evidence rarely determines a single correct theory. Different theories can often explain exactly the same observations. Suppose an experiment doesn't match predictions. Is the theory wrong? Or was there a problem with the measuring instrument? Or perhaps one of the background assumptions was incorrect. Scientists can usually modify supporting assumptions rather than abandoning an entire theory. This is known as the problem of underdetermination. Evidence alone often isn't enough. Scientists must rely on additional standards when choosing between competing explanations. And what are those standards? Things like simplicity, consistency, predictive accuracy, breadth of explanation, fruitfulness for future research. These are not empirical facts. They are epistemic values, qualities we value because they help science produce reliable knowledge. Perhaps no philosopher transformed this discussion more than Thomas Kuhn. In his landmark book, The Structure of Scientific Revolutions, Kuhn argued that science doesn't simply accumulate facts over time. Instead, it operates within what he called paradigms. A paradigm is more than just a theory. It's an entire framework that defines what questions matter, what methods are acceptable, what counts as evidence, and even what scientists consider to be facts. During periods of what Kuhn called normal science, researchers solve puzzles within the existing paradigm. But eventually, anomalies accumulate. The old framework struggles to explain new observations. A scientific revolution occurs. A new paradigm replaces the old one. Think about the transition from Newtonian physics to Einstein's theory of relativity, or from the geocentric view of the universe to the heliocentric model. According to Kuhn, evidence alone doesn't force these shifts. Scientists also rely on values like accuracy, consistency, simplicity, explanatory scope, and fruitfulness. Different scientists may weigh these values differently. That doesn't necessarily make them irrational. It simply means that scientific judgment always involves interpretation. Objectivity, then, isn't about eliminating values. It's about how scientific communities debate and evaluate them. So far, we've been talking about epistemic values, values that help us discover truth. But philosophy of science also recognizes another category. These are non-epistemic values. They include ethical, political, social, and cultural considerations. Richard Rudner made a powerful argument in 1953. He observed that scientists often make decisions under uncertainty. Imagine developing a new drug. How much evidence should be required before declaring it safe? If you approve the drug too early, patients may be harmed. If you reject it unnecessarily, patients may lose access to life-saving treatment. Either decision carries risks. Choosing the acceptable level of risk is not purely scientific. It involves ethical judgment. The same issue appears in climate science, public health, environmental regulation, artificial intelligence. Whenever uncertainty has real-world consequences, values inevitably become part of scientific decision-making. During the last several decades, feminist philosophers introduced another important perspective. Scholars like Sandra Harding, Helen Longino, and Evelyn Fox Keller argued that science has sometimes reflected the biases of the societies that produced it. Consider medical research. For decades, many clinical trials focused primarily on men. As a result, important differences in how diseases affect women were overlooked. Or consider biology textbooks that once described sperm as active and heroic while portraying eggs as passive recipients. Closer examination revealed that this language reflected cultural stereotypes more than biological reality. These examples suggest that hidden assumptions can distort scientific understanding. So what is the solution? Helen Longino proposed what she called critical contextual empiricism. According to Longino, objectivity isn't achieved by pretending scientists have no values. Instead, objectivity emerges through open criticism. Scientists should come from diverse backgrounds. Different perspectives should be welcomed. Criticism should be encouraged. And everyone should have a genuine opportunity to challenge accepted ideas. Ironically, diversity becomes a strength rather than a threat. Different experiences help uncover assumptions that others may never notice. Today, most philosophers reject two extreme positions. On one side is the old belief that science can be completely value-free. On the other is radical relativism, the idea that science is nothing more than politics or personal opinion. Most contemporary philosophers take a middle position. They distinguish between good uses of values and bad uses of values. Epistemic values, like explanatory power, consistency, and predictive success, are essential for good science. Contextual values, ethical or social concerns, are legitimate when deciding which problems deserve attention or how uncertain findings should be communicated. But these values should always be transparent and open to criticism. Modern scientific institutions attempt to achieve this through mechanisms such as peer review, replication studies, open data, adversarial debate, and international collaboration. Objectivity becomes less about individual scientists being perfectly neutral and more about creating institutions capable of correcting human bias. This debate has never been more relevant. Consider artificial intelligence. Should researchers develop increasingly powerful systems without considering their social consequences? Or should ethical values guide AI research from the very beginning? Think about climate science. Scientists must decide how to communicate uncertain risks to policymakers. Being overly cautious could delay action. Being overly confident could undermine public trust if predictions change. The COVID-19 pandemic raised similar questions. Scientists had to make recommendations with incomplete evidence while balancing competing public health risks. None of these decisions could be made using data alone. Values were unavoidable. The challenge was ensuring that those values were explicit, carefully examined, and publicly debated. So, are objectivity and values enemies? The philosophy of science suggests the opposite. Science without values would have no direction. Researchers wouldn't know which questions matter, which explanations are better, or what risks are acceptable. But values without objectivity would simply become ideology. Scientific knowledge depends on both. Objectivity isn't the absence of values. It's the careful management of values through evidence, transparency, criticism, and open dialogue. Perhaps that's the most important lesson philosophy of science offers. Science is not trustworthy because scientists are perfectly unbiased. Science is trustworthy because it has developed institutions that continually expose ideas and the values behind them to criticism and correction. In the end, the pursuit of objectivity is itself a value, and perhaps one of humanity's most important ones. Until next time, thank you for watching.